Hello everyone, this is another video prepared as a part of Kubernetes networking series, and this time I will be talking about Kubernetes services. First I will start with some theory and then show how it really works on Kubernetes Node. So what is the role of Kubernetes services? They are mainly created to represent underlying pods of the same application by providing single endpoint that can be contacted from other parts of the cluster. The important thing is that they are getting IP and domain name. So instead worrying about how to contact particular pod that can be terminated or vanish from the cluster at any time, you just connect to the service that is representing group of pods of particular application. For some time I also thought that service is some special piece of software that is just standing in front of all the pods, like some load balancer or proxy, but in fact service is just implemented by iptables. So basically it's some kernel packet forwarding that is doing all the magic. We will explore it more in practical part, but first let's go through all the types of Kubernetes service. So first one is the cluster IP type. This is just simple service standing in front of all the pods. It gets the IP, which is reachable from the whole cluster, and also it gets the DN in the form of service name.namespace.svc cluster local. So by this domain name, you can reach it in the whole cluster. Then there is the node port service type. It's same as cluster IP with additional feature of exposing port on the node, so it can be reached from outside of the cluster because this port is then standing or representing the whole application to the outside world. And then there is the load balancer type, which is again node port with additional connection to the external load balancer. And this load balancer is provided by cloud provider. So if you are running a Kubernetes service on OpenStack, like in my case, this load balancer will be just OpenStack load balancer. So basically HA proxy that is pointing to port on your node, which is then pointing to the service on the particular Kubernetes worker. You might wonder why we really need this load balancer type. So there are at least three use cases that comes to my mind to justify why the load balancer service type is really needed. First of all, you can imagine that your Kubernetes node have private IPs, so they are not routable from outside of the cluster. This is where the external IP of load balancer could be very useful. Also, sometimes you need TCP traffic, and very often the ingress controllers are like exposing only HTTP traffic. So sometimes if you want to expose some application that is using TCP, you just need another piece that is outside of the cluster to be able to connect to the service. And the third one, if you want to expose ingress control itself, right? So although ingress controller can expose other applications on the subdomains, you need to expose ingress control itself so that it can be routable, resolvable via DNS, and so on. And the fourth type is external name service type. It's kind of completely different from the other three. So you also get the DN, but it's like if you try to reach this DN, you will basically get some external DN in return. So we can point to some external service that will fit into this service representation in Kubernetes cluster. Okay, let's leave the theory behind and switch to practical mode. On the left, I have a worker from my Kubernetes cluster, and on the right, I just have a kubectl command line. So the current situation is that I have 3 pods deployed. Those are basically replicas of same application. It doesn't matter what it does. It's just echo server. We don't have any services yet, and we don't have any endpoints yet too. So what we will do now is to deploy our first service, which will be the cluster IP service. So let's apply cluster IP service. We can also view what's inside. So we have a service definition here. We call it echo cluster IP. We add some labels to it. And what is most important, we are using cluster IP service type, and we are exposing service on 80 port. We are targeting to HTTP port on the container side, and we select the pods by those labels. So if we check the deployment definition, those are exactly the labels that were applied to this deployment. Also, we are connecting to HTTP port, and this is the 8080 port on container side. Can now check if the service was really created. So let's get services, and there it is. We can also get endpoints. And as you can see, we have 3 IPs here. Those are the IPs of all the pods that the service is pointing to. This also proves that our selector in the service was correct. And we can now move to the Kubernetes node to check how it really looks like on the host side. As I already said, services are implemented using iptables. So I can now try to dig out the entries connected with the service that we just created. I can try to grab it by the name. And as you can see, we have 2 entries connected with it. So our service is called Echo Cluster IP. And the first entry is connecting with the traffic from outside of the container network. So we can leave it for now. But the second one is triggered whenever there is a traffic towards this IP, which happens to be also the IP of the service itself. So what will be done by iptables whenever there's a packet sent towards this IP on port 80, which is, by the way, port of our service, we should jump to this particular chain. So let's do it now and once again show what's there. So we again have the same entry that we already had, but we have now 3 entries for all the pods that are behind the service. If you don't believe me, we can still perform a jump to this chain. And see that it is pointing to the first pod from the 3 pods we are exposing using the service. So you can see there is this IP and it's matching the one from the endpoints. So getting back to the rule for the 3 pods altogether, we can now guess what is the algorithm that is dividing the traffic between the pods for this particular service. So each rule here will send traffic to particular chain with probability of 1/3 in the first case. Then if it goes past this rule, which is how the iptables are executed, so they go from the top to the bottom. So if we pass this rule, we now have 50% probability to go to this chain, which is again another pod. And then if all of those were not matched, this traffic will be sent to the third pod. So basically it's implementing the round robin algorithm. Okay, let's clear the outputs in both terminals and try to apply another service. This time it will be node port service. And as you can see, it was created. You can see that our service on 80 port will be exposed on this port on the node side. And if we get endpoints, we should see another set of endpoints, of course pointing to the same IPs, but this time for the node port. So if we switch to the worker node, we can once again try to view the iptables, but we'll be looking for Echo node port service. And again, situation is pretty similar. We have a rule that will be pointing to the IP of the service. If the packet is forwarded to this particular IP and the port, we will jump to this chain, which will be then spreading the traffic over the 3 pods. But what is interesting here also, we have the rule for this external port. Actually, it's here. So again, if something will come to this port from outside, we will jump to this particular chain. We can check what's inside there. And it's basically doing exactly the same work as we did in the previous service. So again, let's clear things here and apply the load balancer service now. So we can do kubectl apply, again get the services and get the endpoints. So we can already see that the load balancer is pending because it's waiting for the cloud provider to spawn new load balancer on its side. Then after a while it should be here. Also, again, there is a mapping of service port to node port. After a while we can check again if the service is up and running. And as you can see, it obtained the external IP. So we can now switch to the worker node again and perform some checks on the iptable side. This time it will be echo load balancer. And we have same parts as we did in the past. So we have this part where the traffic is spread over all the pods. We also have the node port part, basically forwarding packets that the destination was pointing to the node port. But we have interesting part here. This chain. Let's check what is really there. And the interesting part is that there is a rule that whenever traffic goes to this destination, which is by the way the external IP of this service, it should be also passed to the kube forwarding chain, which we see here. So iptables are defining basically two ways to get to the service. One via this node port or the external IP of the load balancer. Okay, we can now deploy the last service, which is the external name service. Again, let's list the services, let's list the endpoints. And now we have another service on the list here. It doesn't have any IP. What it has is the link to the external service, which is Google.com. And it's not adding any endpoints because we are not using any selector for the pods. You can now see how this service is working by starting the busybox in test namespace. And as I said, this service is a bit specific. It's not using any iptables. It will be just switching the DN names. So if we try to look up service name, we should be returned with Google.com endpoint, as you can see here. I also want to show you one more thing. So you don't really need to use this long DN name to get to the service. If you just try on the example of cluster IP service, you can just do cluster IP.demo. Because we are in the test namespace, we need to point which service on which namespace we try to reach. And it's working. Let's remove it once again. And now we can try it in the demo namespace. Because we are in the same namespace, we can reach the service by its name. and it's also working fine. You can find all the resources that I was using here on my GitHub, the link is below the video.